Hi guys, our next topic is going to be inverse trig functions again, but when we did inverse trig functions last week, we were able to use our unit circles. So what if the values are not on our unit circle? We're going to do something similar to what we did last week, where we just created right triangles and used Pythagorean theorem to ensure that we had all three sides, and then we were able to figure out what the question was asking. So our first example here says the cosine of the arcsine of 4/5. So my given information is arcsine of 4/5. So a sine, of course, is opposite over hypotenuse. So it's saying from my angle, the opposite side is 4 and the hypotenuse is 5. Then, of course, we can use the Pythagorean theorem, or you may just know the Pythagorean triple, that it's a 3, 4, 5 triangle. So we know our opposite side is 4, our hypotenuse is 5, and then, of course, our adjacent side has to be 3. So then cosine of this triangle that we just set up using this given information, cosine is adjacent over hypotenuse, which would be 3 over 5. So you're simply going to use what's in your parenthesis to create your triangle first, and then that'll give you what you need in order to use or to figure out what you're solving for. So in this case, we are solving for cosine, which is 3 over 5. All right, let's try another example. This example says the inverse cosine of negative 5 over 13, and we're going to find the cosecant of the inverse cosine of negative 5 over 13. So again, first step, you're going to want to draw your triangle. So we know cosine from our third topic last week. Cosine, our principal value, is between 0 and 180, and that's why this arc is here from 0 to 180. You could also think, if you didn't remember that you know cosine is adjacent over hypotenuse. So you know your adjacent side is negative 5. Your hypotenuse is always going to be positive. So that's another key indicator that your triangle is going to be over here in quadrant 2, because your adjacent side has to be negative 5. Your hypotenuse here is 13. Again, you can use the Pythagorean theorem like we were doing back when we were in school, or, we did this last week as well, to get your third side. So we have our adjacent side is negative 5 squared. You have your hypotenuse, or your C, in your Pythagorean theorem is 13. Solve this out, you get your third side here is 12. So we want to figure out the cosecant using this triangle that we have now. Remember, cosecant is the inverse of sine, and sine is opposite over hypotenuse. So the inverse of that would be hypotenuse over opposite. It's just flipped. So again, sine was O over H, so cosecant is H over O. And we have those values in our triangle. So our H, our hypotenuse, is 13, and your opposite side is 12. So our answer, cosecant theta, is 13 over 12. All right, let's try another one. This one tells me I want to find the cosine of the arcsine of negative 1/2. So again, thinking about our principal values, we talked that our principal values of sine is going to be negative 90 to 90. We know sine is opposite over hypotenuse. Hypotenuse always has to be positive, which means sine, which is our y value, has to be, or our opposite, I should say, is always the up and down. The y value is negative. So that's why you're down here in quadrant 4. Our opposite side is always the y, the up and the down. So when I do opposite over hypotenuse, I do get negative 1/2. So again, use Pythagorean theorem. You know one of your sides, one of your legs of your triangle is negative 1. You know the hypotenuse is 2. We solve this to get B. Our third side is the square root of 3. So now you have your triangle to use to help you figure this out. So now we used our given information here. So now we can solve our problem. The cosine of theta in our triangle is adjacent over hypotenuse. Adjacent is square root 3. Hypotenuse is 2. So your answer is just square root 3 over 2. All right, example number 4. This time it says to find the sine of the inverse tangent of 3. And remember, we could write that as 3 over 1. So again, first step, you're going to want to draw your triangle. And the principal values for tangent is 90 to negative 90. So we know we're working in here. We have all positive values, so your triangle should be in quadrant 1. Remember, tangent is opposite over adjacent. So my opposite side is 3, my adjacent side is 1, and that was given. This allows me to complete my triangle. We're going to use the Pythagorean theorem. I know one of my legs is 1. I know my other leg is 3. And in this one, I'm solving for my hypotenuse. So I have 1 squared plus 3 squared equals c squared, which makes 10 equal to c squared. So the square root of 10 is c. And you can go ahead and just leave it as a square root. You do not have to find the decimal. So now I'm clear to set up to finish solving my problem. So I'm going to find the sine of theta, what I just set up here. And sine is opposite over hypotenuse. So that's where I get 3 over square root 10. And you do not worry about rationalizing the denominator. You can leave the square root down there. That's perfectly fine with me. So there's example number 4. All right. These last 2 examples have variables in them, but it's truly the same thing. So we're finding the secant of the arc cosine of x over 3. So we have to remember cosine is adjacent over hypotenuse. X is positive. X is greater than 0. There isn't a negative there. So I know cosine's principal values are between 0 and 180. But since my adjacent side is positive, I know I'm over here in quadrant 1. So I have my triangle. My adjacent side is x. My hypotenuse is 3. And I got that from this given piece here. So now, using this triangle, you could find the third side. However, we don't need it because secant and cosine are inverses of each other. So really, we almost didn't even need a triangle here to solve this one out. But it doesn't hurt to be consistent and still draw it as your first step. We know that our adjacent side was x, our hypotenuse was 3. Well, like I said, secant and cosine are inverses. So if cosine's adjacent over hypotenuse, secant is hypotenuse over adjacent. So my hypotenuse is still 3, and my adjacent side is still x. So your answer is just 3 over x. All right, last example here. So we have the sine of arctangent of x. And again, I can write this as x over 1. I know tangent is opposite over adjacent. I also know tangent's principal values are between 90 and negative 90. Everything here is positive, so that's why you should draw your triangle in quadrant 1. They gave me the opposite side was x, the adjacent side was 1. So down here, that's why the opposite side is x. The adjacent side to my angle is 1. And you can use the Pythagorean theorem to solve for your hypotenuse. So I have one of my legs is x, so x squared, plus my other leg is 1, so 1 squared. X squared plus 1 squared turns into x squared plus 1. And then to get the c all by itself, of course, we take the square root. And you're allowed to just leave your c just like this, square root of x squared plus 1. Okay, so then the question wants us to find the sine of that angle. So sine is opposite over hypotenuse. So opposite of that angle is x, and the hypotenuse is square root x squared plus 1. And again, you can leave your answer just like that. So that concludes our video for our first topic of week 2 of online learning. If you have any questions, do not hesitate to stop into a help session. Again, they are Monday, Wednesday, and Friday, 10:30 or no, yeah, 10:30 to 11:30, and Tuesday and Thursday from 12 to 1. Have a great day.